Okay, in this problem, they're asking us to find the base of the triangle x. The directions tell us there are two possible values of x. That's because there are two ways to build this triangle physically. They give us one of the answers and ask us for the other. I decided to use the reasoning. First of all, I can't use the Pythagorean theorem, nor SOHCAHTOA, because I don't necessarily know whether or not I have a right triangle, and it may not be one. In fact, it's likely not to be a right triangle. That leaves me with the law of sines and the law of cosines as my formula options. I don't generally like the law of sines unless I know all three angles of the triangle. And so I opt for the law of cosines in almost every case, such as I did here. It's worth noting that in terms of the setup, that I started with the 9 and ended with the 25 degrees. Remember, the order in which you arrange your sides in the law of cosines must be so that the first number and the last number physically oppose each other. Notice in the diagram, the 9 and the 25 degrees oppose each other as an angle and a side. And that justifies the setup here. Now, before I show you how what I assume most of you would have solved this, I just want to make a sort of off to the side comment here. Me personally, and this is just me, I would have chosen to solve this equation instead, based on solving for a different triangle. This is totally optional, but see if you can follow my clever logic here. What I noticed when I saw the 18 and the 9 is that they're in a 2-to-1 ratio. So I imagined a scaled down version of what I was trying to solve for. And my logic is that if I can solve for y using the red equation, that x will be 9 times as large as y. Why would I want to do this? Well, just to have smaller numbers, honestly. Now, that's not something most students would think about, but I wanted to throw it out there as a thought that you could have done. Let's ignore all that and go back to solving this equation here. This equation right here, once we know the cosine of 25 is some decimal, which it is, and the calculator can approximate that for us, knowing that, this is essentially an 8th grade math problem. So I took a calculator, I figured out the cosine of 25. I don't remember the decimal that it was, but I multiplied that by 2 times 18, and I got this equation. I then decided to set my equation equal to 0 by subtracting 81 from both sides, and further, I combined like terms. The purpose of getting your equation in this format, and the reason I call this an 8th grade math problem, is I could use the quadratic formula to solve for it. Plugging in the values of a, b, and c, and doing lots and lots and lots of calculations gave me 2 answers, which we would expect because there is, after all, a plus or minus in this formula, thus leading to 2 different answers. So they asked me in this problem for the smaller of the 2 answers, and there it is. Of course, they had already given me the larger of the 2 answers. You can confirm by looking at the original problem. Now I'm done with this problem in the sense that the answer is 11.504. We're done. But could I just share an afterthought with you? What does it mean that this triangle has 2 possible answers for x? What do I mean when I say this triangle is buildable 2 possible ways? Well, if you look at the original problem, you wouldn't know, because my problems are never drawn to scale. But just to show you what we actually solved for, I used a computer program to physically draw these triangles to scale. And here's what I mean by that. These 2 angles actually are 25-degree angles, as close as my computer drawing could get them, which is probably pretty close. It's a computer-generated drawing. These 2 sides are actually 18 centimeters, not probably on the screen you're viewing, but on my screen they were. And these 2 sides were and are physically 9 centimeters, at least on my screen. And you can see that there are two physical ways to build this triangle based on the specifications in the original problem. And it's not surprising that when we solved using the quadratic formula and got two answers, that those two answers represent the two possible bases of this triangle. In the blue picture on top, the smaller triangle has a base of about 11.5, and the computer program did verify that. And on the bottom green triangle, the base is clearly larger and is actually, in the physical world, 21.1 centimeters approximately. You don't have to draw these to scale, but I thought if you're going to solve a problem with two answers, it'd be nice to know physically what those two answers represented. And that finishes the problem.